Welcome back. This is Nick Eger once again. Some examples of, on the topic graph of the sine function. Without using technology, sketch graphs of y is equal to 2x. As you can see here, 2a is equal to 2. So our amplitude, it should be 2. The same period. This is your y is equal to sine x. So our period is the same, but the only difference is that we have our what's that? Our maximum point is on 2. Maximum point on 2, and the minimum point is -2. So if we start doing that, then it should be like this. Sorry, I missed that. Okay, it should be like that. Okay, how about B? We have our amplitude is still -2, is 2, because we have the absolute value of A is 2. But if we're going to put the graph here, it will look differently, because since we can start instead of we have the first maximum value is 2, then now we have minimum value. Minimum point, no, not value, minimum point. Here is our maximum point instead. So the red one now is y is equal to -2 sine x. And the blue one, we have y is equal to 2 sine x. Okay, let's take some more example. Without using technology, once again, sketch a graph of y is equal to 2x. As I discussed in my previous video, we have b here. So it's the period we're talking about. Then we have 2 pi divided by b. We need to do that also. Okay, so we have our period now is equal to 2 pi divided by 2. Our b is 2. Then we have pi. That means our whole period now ends here. Then our half period will be here. It should look like this. And then we have here 1 minus 1. It only says here that we will double how many period it is to 2 pi. So we have here once again, and here. That's it. It should look like that. It is not that accurate, but it should almost look like this. Another example on the same set of axis graph for up to 4 pi is that we have only 2 pi here. But let's see. We have 3 pi here. I think it's enough. Okay. Then it should be sine x. We have already sine x here. And the sine x minus 1, what does minus 1 do there? We have C there. Affects horizontal translations of when it is C is greater than 0. Then we have on the right. So if we're going to look here now, that is not the one. Here. So if we are going to put this point, 1 point, if we say 1 point there, okay, that means this also 1 point there, and then 1 point there. I think so. That's all right. So that means 1 point here also. It should be like this. It should look like that for this one. Y is equal to sine x minus 1. Okay, how about the other? Y is equal to sine x minus 1. This one. This is D. That means it affects the... It's good to go back. It affects the vertical translation. So from 1, if we can start from 0 to 1. We have minus 1 there. From 0 to negative 1 here. So it's the same. The amplitude is still 1. So this is our maximum point, and this is our minimum point. Maximum point, and then continue. It looks like that. Okay. Next. State the amplitude where appropriate of, we have tangent and cosine there. I'm not going to solve, I'm only solving for the sine. I will solve the tangent and cosine later when it is their time to, when we have discussed them. Okay. Then we have our A. We know that we have this look like this, 1 times sine 4x. The amplitude is our A, so our A is equal to 1, the absolute value of 1. So our amplitude is equal to 1. Some more. State the period of, we only look for the C there, C. We have our sine. It's look like this now. Y is equal to B x minus C. And we are only interested for the B. So we have B is equal to 2. So period now is equal to 2 pi divided by 2. Then we have pi. So one period or one cycle is pi. More. Only for the sine, we have A and D. Find B, given y is equal to sine bx has period 2 pi. So we have for A, we know that period is equal to 2 pi divided by B. So B is equal to 2 pi divided by period. So we have 2 pi divided by, our period is 2 pi. So our B is equal to 1. Okay. For D, we have B is equal to 2 pi divided by, our period is 4. Then we have pi divided by 2. our b. Okay, some more example. Maybe this is the last one. We have state the maximum minimum values for appropriate. We have the minimum values, then maximum values. Then we need to find the amplitude first. So our amplitude A is equal to, here we have absolute value of -1, then it is 1. So for A now, because it's the sine, our maximum point, our value is equal to 1. Minimum value is also 1. And then we try E. We have A is equal to the absolute value of 2. And then we have that is equal to 2. This is our A. So our maximum value is equal to 2 plus our D there, 1. That is 3. Now, before we will continue for the minimum value, I will draw a sketch of this. Okay. Then we start with 1 here. And then we go 2 steps. So it should be, this is 3. So this is our highest. And then from our starting point, we have also amplitude 2. That is 2 here. So if I'm going to put the value there, it should look like that. So we have now our minimum value is equal to -2 plus 1, that is -1, as you can see there, because we have absolute value. Okay, the distance between the principal axis. Okay, for our F now, if I'm going to do a sketch for that, I will try. Okay, it's not that bad. Okay, then we have our -3 is our starting value, 1, 2, 3 here. And then we have amplitude 1. So our highest is that one, and our lowest is this one. So our maximum value here, is equal to -3 plus 1, that is -2. The starting point plus the amplitude, our amplitude is still here is 1. And the minimum value is equal to, we have -3 minus 1. We have -4, as you can see here in the sketch. Okay, thank you for watching. I hope you learned something, and in my next video, I will be discussing the cosine function with a lot of examples also, like what I did with the sine function. And see you around. Have a nice day.